some I see some other people joined the new link, so thank you everyone and welcome to the group. Carlos, I know you have been in with us for a long time, so I'm excited that this time you get to present. Okay. So as usual, I'm gonna ask everyone to please help me with changing our names. So we're gonna use the same style or name, country we're working from, and the testing center that we represent. Okay. So I'm gonna give everyone a couple of seconds. You can go to participants, and on the right side, you're gonna be able to see a little icon on the right that says more, so we can change our names there under rename. Okay. Okay, thanks. So let me find my mouse. Cool. Okay, awesome. So for today, we have some updates that I would like to share with the entire group. And then we're going to have 3 presenters, as I mentioned before. The first is going to be Steve Williams. Some of you met Steve last week on the ISWP Standards Working Group. He has a lot of questions related to testing, and I think this would be a great group for him to be able to ask the questions to, since a lot of you have expertise on this. And I hope that we can help Steve to find a lot of solutions on what he's working on. We're also going to have Carlos Costa, who's going to be showing us the virtual models to evaluate wheelchair testing, as he mentioned a couple of minutes ago. And at the end, we're also going to have Nichole Orton from the University of Michigan Transportation Research Institute. Okay. So I'm going to start with some quick updates on my end. And that is because we are going to be merging this testing centers group with the ISWP Standards Working Group. We noticed there's a lot of overlapping topics, and some people who are in the ISWP Standards Working Group are having questions about testing. So we thought it just makes sense to put them all together. That group typically meets on a similar format that we are doing. So every 3 months on the second Wednesday. So the next meeting, it's going to be merged between these 2 groups, and it's going to be on December 14th. And so on, it's going to be December, March, June, and September. You please expect to have a new calendar invite where I'm going to be sending the update for joining the December 14th meeting with the Standards Working Group. So you may be receiving a couple emails. Sorry for so many emails if that is confusing. I'm going to try to first cancel all the meetings for the testing centers, and then I'm going to be sending the Standards Working Group meeting. So from now on, our meeting name is going to be Standards Working Group, ISWP Standards Working Group. So just in case, I just wanted to let you know about that. And the second part is that our time is also going to change. So I know that we are meeting right now at 9 a.m. Eastern time. We're going to be moving it to 12 p.m. or noon until 1:30 p.m. I have a little box here that says a couple cities for taking a look at the different time zones. But if you have any questions about the reasoning behind changing, let me know, and I'm happy to help, and maybe we can find a way to do this as well. Okay. So how this Standards Working Group has been working is they actually were started a long time ago, and they have been addressing different ways to either do testing or how to develop new products, but also it's a very open group, and they always provide a lot of feedback. It's a very amicable group as well. So I think you guys are going to enjoy that. And with no further ado, I want to introduce again Steve. And please feel free, Steve, to start sharing your screen. We're gonna hear soon from him. And also feel free to introduce yourself to the group. This is a new group. You may know already Jim and Bob, as well as Dean from the previous meeting. But today we also have here Bill Ammer and Kara, who both of them have a lot of expertise in the sitting and standards world. So I'm sure that both of them can help you a lot. And with Carla's experience, I'm sure that also is going to be a great help. I see that we have on the call Evan Cole, who also joined us. This is the first time Evan is joining us. So thank you for being here. And thank you everyone else for being in the call. I see that also Stephen Peters is here. So welcome. And please feel free to jump in with feedback. I know Steve has some questions for you. Thanks.
Okay, thank you. Can I share screen now or not? So let me just check in.
Yes, you can share.
I can. Okay, great. Is that working?
It is.
Okay, great. Thank you. So yeah, I won't bore the people who were on the other call for too long with introductions, because I would love to get over to the tests, to what we're doing, and ask questions about the actual tests themselves. But just I'll give a brief description for those that weren't on the call. So my name's Steve Williams. We have an organization out in Uganda. For the last 9 years, we've been really concentrating on therapy and rehabilitation, and that's what our core work was. And then we've moved into education and now mobility. Mobility was basically out of the need to get enough mobility equipment, from crutches to wheelchairs. We just couldn't get good quality, terrain suitable, and of course, yeah, affordable. So I'll just give you a little bit of the background. So my son was born with epilepsy and a permanent development delay. So yeah, that sort of opened up my eyes, as I suppose a lot of people who experience disability, it does, and decided we could not just help my son, but see if we can help many more. So yeah, it started, as I said, with just rehabilitation and therapy. So that's like speech, occupational, physio. But that team has grown now to 85, and we see about 1,000 children every month. Yeah, it's just that the need is enormous. Like, we cover West Uganda, as you can see from some of these stats, but we are staying as much as we can in West Uganda because it's just, we want to keep the quality high. But the wheelchair project, we hope to have give throughout Uganda. So Kyaninga Mobility was set up, as I said, it was out of the real need for the equipment. We just couldn't get it. The stuff we got donated from abroad would normally be secondhand, very hard to get children's equipment. It would quite often not fit. We couldn't get the spares. So it was all sort of very difficult. These are some of the chairs we've been working on, which I'm going to swap over in a minute, and we can just go straight and see the chairs and the testing machines. But we've tried to do where we can to get users that we can work with. So it's quite difficult, because like all our children that we work with, most have never had a wheelchair. So they've spent the whole time on the floor. So we realized that we weren't getting much useful feedback, because so many kids are just left on the floor. So we've been giving some kids wheelchairs, and they're like, yeah, it's the best wheelchair ever. It's brilliant. And you're like, well, probably not. So we got a lot to work to. So we've actually, for now, we're just moving back. We're going to make a few more adult versions because we come across a really good network of users who do a basketball, and they've got like basketball chairs worth sort of $10,000. They've got really good chairs. So it'd be good to compare ours to that standard. So they're going to be coming down each month we're going to put a competition on and use our chairs for the actual event, but also test all chairs with that network. In the picture, there's actually one of our guys, is Rogers. He lost his use of his legs through it's actually a disease that he got in his spine, but he wanted to be a ballroom dancer again. So another great opportunity to have a user. So that was really key to get the center of gravity perfect, all the spins, the durability. So he's been a really good help. We're working on, at the moment, we're trying to keep it just to the 3 wheelchairs. So a standard wheelchair, the ballroom dancing wheelchair, obviously not going to be a huge amount, although I think they're looking at starting a Ugandan ballroom dancing team now. But it's the standard wheelchairs that we really want to work on, and then develop until we sort of have a range of around 10, 12 wheelchairs. All of it is we just want to keep developing. That's why we want to make them in country and not send them off to China. So we'd love to be able to make batch production here. So I think, if it's okay, we'll take you over to see some of the wheelchairs we're working on and the testing, if that's okay. Any of you on that one? Okay, I think we're going to swap cameras. Is this working?
Yes, I'm gonna actually put you on the spotlight so everyone can see you a little bit bigger. Okay, so if you guys cannot see Steve very well, I would recommend you to go to the view side on the top right corner and select side by speaker on your computer, and you can slide it so the camera that Steve is using is going to be bigger on your screen and you can see him better. Thank you, Steve. Yeah, we can see you.
Okay then, Pearl, do you want to come and take it? If you swap it around the other way. Yeah. Okay. Can you hear us okay if I move back this far away?
Yep, I can hear you.
Okay, great. So yeah, this is one of the chairs. This is more of the standard chair, but with a trike. As you can see, we're butchering all the chairs all the time. So when we can actually move the caster wheel backs and forwards. We can move the front wheels. We're trying to find the best center of gravity so it doesn't tip. This is for a child. Why this is so high up? It's for a particular child that had a very high waist. We've tried different strapping. I don't know. I guess that's the problem with that throughout Africa. We've tried all the different strapping, and to be honest, nothing works. We have it over here. Where we leave it, and every week we measure the distance. And apart from we've moved back now is to seatbelt strapping. The rest just keeps giving basically 1 centimeter every week. All the strapping we can buy is given, so it becomes very, very saggy. This is the sports wheelchair. This is version 3 of this one. So many things are changing, but essentially what we're very excited with these chairs is that the bamboo is incredibly cheap, and we found a way to fix the bamboo. That has been our mission really from the start, was how can we fix bamboo with very cheaply. We tried 3D printing for a year. We tried, obviously metal brackets, they were too heavy. We tried other plastics to join. And what we've done is we've created a machine to fill the bamboo with more bamboo. And then a machine that shapes the core to go in, and then we can use traditional woodworking joints. So this is now we can do more like simple miters with the webbing. And that side of it seems to be going really well. So we've done quite a bit of testing on dropping it. So if we can now start the real nitty gritty of getting, as I said, the center of gravity and everything else correct, we feel we can make much quicker progress. Should we have a quick look at some of the testing machines? So the 2 you've seen are probably going to get broken quite soon. We've set up so that we can this hopefully following Dr. Perlman's, so that we can do the actual seat itself. Same with this one. These are all correct weights done from the ISO test that we got. This is for tipping. So there's a hoist that tips. The trike obviously is the one that we're really worried about, getting the wheels so it doesn't tip sideways. This is our dummy. We put weights in, which we were given the design for, so that we can hopefully share data. We then do trailer tests. So we take trailers that we fit on the back of the vehicles and then take them around town, so that we can basically, all the technology is the same as what we use for the wheelchairs and the walkers. But we can see then how long the hubs last, how long the joints, the sprockets, the bearings, so that everything gets a good test. We've now given similar ones to guys in the village to use to take bananas and crops to market. So we thought that was a really good in sort of local testing, going over all the local potholes, getting it to market, unloading it. I think that's all the testing. So what we wanted to ask was, what other tests should we be looking at? Should we be building that we can sort of do in this country without sort of importing very expensive machines? Right.
Does someone in the group have any insights for Steve? maybe Bill, you have been working a lot with wood and other materials. Do you have any suggestions?
Well, the dummy looks really familiar. Looks pretty much like
Yes.
the ones that I use. You know, I like
I
the,
forgot just to show you briefly. I forgot to show you the we have a carousel. So we can pull 4 wheelchairs around and around. We're going to make a course for it now. I should have just showed you that one before I finished the. So we just leave that running, I think, all day that the workshop's running, and we'll clock its kilometers. So yeah, that was the one more machine. Sorry to interrupt.
do you have any plans for a fatigue test, like a drum test?
How does that work? We've got a pen. A fatigue test?
Like the drum test?
Oh, okay. We were looking at the drum test to test the casters. Is there a drawing of that? Is there a drawing that we can use to build that?
There is. It's in the standard. Stephanie, I can get it to you if you can get it to Steve.
Yeah, that would be great. Thank you.
You know, and there have been alternatives to that. Usually the drums are steel, but I've seen some modifications made where you can use a piece of plastic pipe and fill it with you know, I've seen some filled with concrete, some filled with dirt, just to get the inertia right on the drum.
Okay.
And so that would be reasonably inexpensive for you to do it that way. I'll put some notes together and get them to Stephanie, and then she can get them to you.
And then if we were to, if we put these tests together now and we start, because they're all going to sort of start up in much quicker concession, would you be willing for us to send like some videos to you, and you sort of maybe could give us a little bit of feedback if we're making progress, or share some of our data and maybe get a little bit of feedback? Oh,
absolutely. Anytime.
Okay. That'd be amazing. Yeah, that's what we really want to make sure we are going down the right path now, as we really push for the sort of the longer tests and this build up the data. We've got a good data test sheet that we can also share, because we're doing a lot on finishes as well. It's obviously here in Uganda, it's very much dry, wet, 2 dries, 2 wet seasons a year, and that really affects so we're looking at many finishes. Things like that would be really interesting as well to share from other people around the world of how they've got around these things.
Don't forget, you've always got Dean down with Shown Equip down the bottom there. He's recently built himself a rolling road Part 8 durability test rig. He could lead you through it by the hand, I think.
Yeah.
Okay. I can contact him.
And then we have some other resources also on the website, and that is the video that Dean actually shared with the group a couple meetings ago, sorry. So I'm sure that maybe you can take a look at those resources, and for sure Bill's drawings are going to be very helpful. And in the future, if you want to keep getting updates and feedback from the rest of the group, we can continue to do these meetings as well, where you can ask further questions if that helps.
Yeah, especially because around one particular area that we're struggling with, or we want to develop. Like we just really want to be as rigorous as we can now, especially on those joints, to make sure that technology that's taken such a long time to develop, to get the strength, and we want to know that that's right. And then, I know I was going to go and meet the guys from Whirlwind in 2 weeks in Berkeley. So I think they've also got a lot of data on African bearings and spokes and hubs, so they're willing to share that. So that sort of data is going to be invaluable to give us a head start. Otherwise, we're going to be, needing to do sort of 10,000 kilometers on everything to see what really works. So I think we've got a head start coming up there. I don't know if you guys worked with the guys from Whirlwind at all in the past.
Mm-mm.
I have a lot of nodding faces saying no, unfortunately.
Okay. Yeah, they've been since 1985 making wheelchairs for the African continent. And I think they've got their wheelchair in 60 countries. So I thought it'd be a great chance to go and have a chat with them and see what they've learned over the years.
Steve, this is Kara. Forgive me, I did take a call in the middle, and so I may have missed a bit of your video, but do you have the impact test that uses the soccer ball on a pendulum?
Yes.
Okay, yeah, that's a nice, dead simple one to give some durability confidence.
Yeah. Thank you. We got that. We got one with a ball and one with a straight plane piece of metal, and we followed. Yeah, we got sent the dimensions and the weights. So ours is made of metal weight inside, concrete on the outside, then a little bit of sand. But we were suggested in the last meeting that maybe we try making one with nuts and bolts as well.
You know, Steve, Jim and I were talking after last week's meeting, and we were saying the pass-fail criteria for Part 8 and durability and all that is fantastic. But I think that your conditions and that you're working in are going to kind of call for more. So it might be you'll end up with wheelchairs which are Part 8 compliant plus for the African factor. So, you know, I won't get hung up on too much detail, because your conditions are far more arduous than we'd see in our neck of the woods. Yeah.
Well, that's why I thought giving these carts to the guys, you know, who take their goods to market is a really, I know it's hard to get sort of clarity data from that, you know, how long they've kept it, but it's really is using it on the roads. The wheelchairs are going to be used from it is the same joints, and it's very if we can get a bunch of those out, we should be able to see if there is any weak spots or you know, sort of like, it's not going to help us with the getting the center of gravity, getting the tipping right, but it is going to give us sort of probably throw up some really on the ground problems. Like one that we've already realized is that if you take a wheelchair in Africa to a school, everybody jumps on it, and you're just not going to be able to control that. You're going to have to accept that if there's a rail, their mates and friends are going to be standing on that, and no one's going to be stopping them. So you need your wheelchair to be able to carry 4 or 5 people and be used a bit like a toy, which obviously we'll try our best to work with the teachers and the schools, but that's something that we're going to have to accept.
ISO 7176 Part 33, wheelchairs for multiple occupants.
Okay.
Yeah. There go, Bill. That's working group 1. So that's your first job, Bill.
There you go. Thank you, Rob.
And we realized another thing we got to do is when we give out these wheelchairs, when we get closer, is that we make sure that if it's a speciality chair for like sports or the ballroom dancing or anything, make sure they've got a standard chair. So we've given out these ballroom dancing chair, and they love it so much that it came back and we're like, how did you break this? He's like, well, I dragged it along the beach for miles because I wanted to show all my friends. I was like, that might explain why things were getting bent. So yeah, make sure that when we do it, they always get given a standard wheelchair for moving around, like an off-road standard, and then the speciality one as well, because they are literally going to, they're so proud of it.
Steve, I have a question. So when that happens and something either bends or breaks, is it easy to repair with the material that you're using?
Yeah, so what we've done, anything that was developing that couldn't be repaired easily, we just sort of stopped that train of thought. So everything is bearings you can source. We have to strengthen up the hubs of the local wheels, but those bearings are available in any bike shop or mechanics. So they can repair the 4 bearings in the wheels. Everything, basically a bike mechanic could repair it. And then that's why we're really keen for the main structure to not break. That's why we're sort of almost oversizing our components for, let me just turn you around, like we're oversizing the bamboo really, so that we can really, we don't want these joints to ever break. This would be something that has to be, for the life of the wheelchair.
And are you using some kind of like covers, maybe with some type of fabric to protect maybe sharp edges for the user?
Yeah, like for the bamboo, it's all very soft, but we were thinking, we're going to need some more guards on some of them. Yeah, like what we've really struggled with is getting 100% cotton. we're not going to be able to it. At the moment, we've been looking at buying even t-shirts. There's a lot of secondhand, I know it's not ideal, but a lot of secondhand t-shirts that are still in very good condition, 100% cotton, that might be a source, but we can't seem to find anybody supplying 100% cotton, which we need to stop anybody getting bed sores.
Yeah, I know that, well, as part of the WHO basic training, when they do the cushion and they are in low resource settings, what they tend to do is the fabric that's going to go on the cover of the cushion itself tends to be like the active shirts. So you're gonna, the sports shirts, that's the kind of material that they are using with some cushioning inside, because that's going to be soft to the skin and it's going to allow them to breathe. And I'm not a cushion expert, but that's what I know it's being done in less resource settings. But I know there's other people in the call that may be able to provide more feedback on what materials could be used for that. But so if someone knows more about this, please feel free to jump in.
One of our plans, just to say, was what we were hoping to keep if we can get it comfortable with the strapping, was to keep the foam as thin as possible, but still comfortable. If we can get high enough density foam, which is very difficult. There's only 25. What's it, RD? What's the rating for foam? IL. Yeah. So we're trying to see if the manufacturers will go up to like the 75. We've asked many, but we haven't got any positive feedback. So then if we could go with thinner foam, we could then put in behind the back seats, we could have at least one or two changeovers. So if they do get wet, they don't leave them damp. They change them over, then they can wash them in the evening and put them out to dry.
Awesome. Thank you, Steve, for sharing. Do you have any other questions you would like to ask to the group, or does anybody in the group would like to ask?
I have just one question. Here's Carlos. Please, the joint elements that you have put in the wheelchair. I saw in the last picture that you show us is the footrest. You have screwed in the bamboo. Is a screw that you put there to join the components of the wheelchair.
Sorry, say that again. You said it.
I saw in the last picture that you have shown of the wheelchair to join the footrest and the base of the wheelchair. It seems to me that you have a piece of wood and screw in the bamboo. This is all bamboo as well. So this is laminated bamboo, and then this is all raw bamboo. Okay, but how you fix the bamboo with the other woods? Is a screw that you put, or glue, or what kind of?
No. All these joints are glue.
Yes. This one.
Yeah, they're just glue with then dowels. So we got 3 webs. So there's 3 separate webs. We tried with just the 2. It was pretty strong, but the middle web really makes a difference. So we got a middle web and then 2 outer webs. So we're actually making a machine now to kind of cut this all very quick so we can make everyone the same. But with the 3, then it seems to be, we might get away with 2, but we're gonna keep testing with these new testing we're doing.
Okay. Because the resistance is okay, but I wonder about the time, how long it takes to get some clearance and start to falling apart. I mean, to get some movement there.
Yeah, we have got access to a very good outdoor glue here, which is one of the graces that we have managed to get. So they do import a glue is available in country that is designed for exterior use for woodwork, and that seems to be holding. We've also got tests outside of our joints and letting them be aged, but so far it seems really positive. The joints are not breaking down; they're not coming loose.
Okay, thank you.
Hi, Steve. Yeah, just quickly, I just want to ask: have you looked at bamboo bicycles?
So we went to see, there's a bamboo bicycle shop in our capital city in Kampala, and I went to see a few in the UK. They use 2-pack resin. The problem with the resin is it's incredibly expensive to get here. It's because it's hazardous. So he creates like just the frame of a bike without any wheels, any parts, not even the inserts. And his cost price is just under $300. We're trying to produce the whole of that wheelchair for around $260. So we just, we're never going to that much.
Because I've seen others, they use bamboo frames for the main frames and use carbon fiber joints, you know, obviously, which is to put the bamboo sections together. Yeah, so that's not ideal. I just thought there could have been some ways of making them. Yeah.
Yeah, like the filling of the bamboo, it seems so obvious when we did it, but yeah, it seems to work really well. If you fill the bamboo and just that last 4 inches, so you haven't upped the weight too much, just the last 4 inches of the bamboo we're using the design that's a bit like how they used to make clogs, shoe clogs. You can have it's like copies one to the other. So it's like a follower that follows the inside of the bamboo. And then the other side of the machine is cutting the plug to go in it. So you want to put a component in, cut a plug out of laminated bamboo, and then just plug them in, because obviously every bamboo is different to make it quick. And then suddenly you've got something very strong, because otherwise, you're just joining two hollows together. We just couldn't find a way to get around how to join these two hollows together.
Yeah. I mean, I suppose it's there's different types of bamboo then as well.
We would love to get more here. We've got two available types, so we're designing everything around them, but we have a forest foundation as well, so there's a lot of companies coming over and starting to plant bamboo, so we're looking at whether we could work. We've got about 1,500 farmers. If we were to buy it from them, they maybe could start getting us all different sizes of bamboo. Okay, thanks.
Thank you, Steve. Thank you everyone in the call also for providing feedback. Just because of time, I think we're going to have to switch with our next presenter. So I appreciate everything that you shared, and I'm looking forward for also people in the group giving you more feedback in the future. So I'll send you an email with some resources, and I'll share with you everything that Bill's going to share with me. Okay.
Thank you so much. Thank you, everybody. Thank you very much.
Thank you. And Carlos, you're up next. If you want to continue, you can share your screen now.
Okay, I try to to share my screen. Let's see if it's work. Are you seeing the presentation?
Yes. Yeah.
It's a full size. It's full. Okay.
Full screen. Yeah.
Okay.
Carlos, can you get closer to your microphone? It's difficult to hear you.
Sorry. Microphone, but I try to speak louder. Okay. Can you hear me?
Thank you.
Okay. Thank you for advising me about this. This presentation was invited by Stephanie because she saw in my LinkedIn. Then she invited me to do the presentation. It's a presentation in a little different way that the group has been working. It's more for virtual models. And one of the motivation was that companies in Brazil do a lot of tests in the official testing centers to homologate the wheelchair. And one way that they are considering is see how we could use virtual models to, let's say, go down number of tests, not exactly to stop the tests, but change a little of this. The main work of this work was author was Giovanni, who did his post-graduation work. And it's an initial work on the subject. The company who sponsored the wheelchair and a cooperation project was Freedom, which is a huge company. I think it's the biggest company in Brazil in this area. We have used an actual motorized wheelchair to do the tests. We have used ANSYS tool. It's a finite elements analysis tool. And the simulations was performed initially only on the linear part of the the model. I explain later. Loads with different magnitudes were applied, and we have used specifically the ISO 72176, the part 8, specific parts to test. It's an initial test that we have done. So we took the full geometry model of the wheelchair. We have turned to a simplified model, and then finally a final model which we have used to analyze. It's important to say that we have took all of components that don't make any difference in the structural part. Like we have here the control, so we haven't used this to the test, only the main frame of the wheelchair. We have tested 3 situations. The first one was about the armrests. We have applied specifically how the standard says, the loads and everything else. So here in the right side, we have the virtual model. I explain later. We have tested also the foot rests, the force also here. And this one specifically, the standard talks about the adherence of the handles. But in this case, we have tested how behaves the wheelchair structure when you are pulling the wheelchair like a pass walk side that you put, and how the structure respond to that. So we didn't check actually the adherence of the handles. To do the test, we have considered also the part 11, which states about the dummies, and we have considered the 3 center mass or superior part of the body, and then the thighs here, and below the knees, the leg, the whole leg. So we considered a user of 100 kilos to do the test, okay? The wheelchair is about 120 kilos, but we considered 100 kilos and made all the calculation to this. So after doing the finite element mesh, we have done all the connections. And here comes one important thing that it's how we design in the virtual model the connections of the part of the wheelchair, like welded connections, bolted connections, the tolerance, the clearance. We have to take in mind, we have to have in mind that the virtual model is quite, let's say, perfect. So when we test one wheelchair in some equipment, you put a load, a force in one specific point, the wheelchair absorbs in another part of the structure this force. But when you do in a kind of the finite element analysis model, it's a quite specific. So he considers that the rest of the wheelchair keeps rigid. So this part is important to take in mind, because eventually you can have a different result. Okay, so we have all the connections, the caster wheel, the drive wheel, how we fixed the model this. And then presenting the conditions. So the first condition, just to show, we consider the user seated, and all the weight of the seater is distributed by these 2 bars, where is the actual seat. For this wheelchair, it is manufactured with steel ACE 1008, cold rolled. And from this, we took the tensile strength out. this is the part when I told you that we have considered only this part of the property of the material. We call this part elastic. So we have then didn't put in the software the second part, which is the plastic, where the deformation actually occurs of the material. We call the plastic part. So we have to put a hyper-elastic part, which is a little more complex. And all the data is in megapascal. There is a mistake here. It's a capital P. So for the user seated, it's quite easy. All the maximum tensiles in the distribution of the wheelchair, no big deal about this. Then we come to the second condition, load concentrated on the armrests. And in this case, the standard is quite severe because it puts quite a lot of, I don't know if it makes sense, but okay, it's the standard. And we put exactly how it says. In this case, we can see that considering the tensile strength 284, we had about 297 and 296. But this is an explanation because we have considered only the linear part of the model. So that this specific value doesn't mean that occurs deformation. But okay, let's go on, and then I show you one test that we have done to check this. The third condition, we put the loads on the footrest. And then in the first moment, the results get quite strange. But then the manufacturer told us that they are using two different materials here. The SIA 1008 called rolled in the superior part, and the inferior part, it was another SIA 1008 drawn, which changed the property, the values. So in this case, we see that it was quite critical. The weight here, it was 100 kilos. It's almost, it's amazing the structure that you have to do this physically, no? But we have done physically, then I show it to you. But the results was quite critical. But okay, it seems that there was a little of critical here that must be seen for the standard. And the last condition was pushing the handles to get up in the walk path or something like that. And the main tensile was occur here in the column of the wheelchair, but below the maximum tensile. In order to check some of these results, because, okay, I have a virtual model, makes sense, doesn't make sense. We have exchanged a lot of information with the manufacturer because they have tested this wheelchair in an official center test, but they didn't get the results by numbers. They only get the results, okay, pass, no pass, in the test. So we have put some instruments here, and we put a string gauge to get the values of the deformation and the tension. And we did a test with some calibrated loads. So we have used here, but of course that you have put a little thing that doesn't appear here to simulate exactly the same condition that the standard says, and the same that we have used in the virtual model. So for 20 kilos, for example, we got 63 megapascal tensile. And then we have done a comparison with the experimental tests and the virtual tests and get some results here of the deviation, which is not bad when we consider for the first model, considering a little of things that was not perfectly informed to us. But anyway, when you have a deviation about 10%, I'm not saying that's okay, but it's quite good for a general model. So we have test this, and just concluding this first work that we have done. It's a good and a reliable solution. It's not bad. In fact, we have an idea of like in the automotive industry, we can test physically and calibrate the virtual model for some sections of the wheelchair. And then when you change some part of the wheelchair, there is no need to test all the wheelchair again. You can only adapt that part in the model and see how it behaves. So the main issues related to the material specifications, this is one part that we have problem is, okay, what exactly the specification of the material? What exactly the mechanical properties? We were not convinced about the mechanical properties. So we asked for the manufacturer if you could make some destruction tests in one part of the wheelchair. We took apart and make a traction test to elongation test to see if the tensile strength was the same that the manufacturer was telling us. So you have to prove if it was. It was okay. The difference was about 10 megapascal. It was okay. But also we can exchange these to other physical tests, tensile, impact, fatigue tests. And this is the information that you can input in the virtual model and try to simulate another situations. This part of the realistic models is the main issue, in my opinion. We have to always, although I'm doing a virtual test, I have to check and calibrate the model. So I cannot just do the virtual model and say that's correct. But as the tests are doing, we are doing the test, we are getting some confidence in the virtual model, so you don't need to do all the physical tests again. And as I told you, one idea that we have is creating an architecture that defines subsystems of the wheelchair. And then once you have the comproval that this part is okay, you don't need always to test the whole wheelchair again. You only test the parts that you are changing in that configuration, because the other ones are already, let's say, tested and validated. So the work, sorry for my English, but the work in essence is this. It's quite different than what the group has been presenting, but I'm ready to listen some considerations or questions to try to answer.
Carlos, how long did it take you to do the actual modeling of the wheelchair?
It was easy for us because why? Let me explain why. No. I understand what you mean. We received the full geometric model, virtual model of the company, because the company has to design the product. So they have all details designed. So we received that. Our main work was to take parts that we were not considering for the test, and mainly doing the joints, how to configure the joints, because you have to be very specific on this, otherwise you can get big errors on the model. But saying more objective, this student took this work, decided to do, he did it in about 2 months and a half.
Okay.
Well, he knows about finite element analysis, okay? He's an engineer, he knows, he's from this area.
Yeah, hello, Costa. Yeah, I think that's it's really good that you're actually doing calibration of the model. I think that's vital, rather than there's too many people just do FE models and leave them as they are. I was thinking that are you looking at any of the joints specifically, rather than just the tube sections? Because
Yes.
the joints are really what's giving the strength, and different joint designs are crucial.
Yes, the joints in this work we have considered welding, screws, and you have to define in the software also how one element, let's say, related with another one. For example, for the footrest, I say that that component only have one tube inside another, so they are not connected. There is a little clearance, but there is no movement between centers, only longitudinal movements. So I have to consider all these details, otherwise you get a model is not realistic.
Yeah.
Yes.
I mean,
It's
certainly
difficult.
if you're going on to doing a dynamic test, part 19 test, you'd really want to know the collapse performance of those joints. And yes. But I think your results showing 5-10% or so. I mean, that's very good. To get that sort of level of correlation.
One thing that the company likes about this work was, well, two things. First one, when I'm sending the company, when they sending the wheelchair for a test, homologation test, they want to make sure that's only a pro form. Okay, I know that my wheelchair is okay. And the second one is to see in what way this wheelchair is over-designed. Because usually, as the first presenter said, eventually you go to his wheelchair, it's a multi-platform wheelchair, everyone goes up. So you have to decide the limits and say, maybe here I'm using a thicker tube that I need. I don't need this. And this, in the end of the day, is shortening time, manufacturing process, and money. So it's a way of that.
Okay, thanks.
Okay.
I was pleased to see your results. Those are the places where your model showed that you were over the stress levels for the materials are exactly what I see here as far as failures. Those are all the same places that I see chairs fail when I run them on the drum. So I think, and you showed your results, and Jim just mentioned that you're within 5% of actual versus virtual. That's pretty impressive.
We have been very thoroughly on this model because we didn't have much time for the students, so we said, no, let's take all the information quite precisely. Because we asked for the engineer in the company, then they say, oh, it's a kind of steel. And then said, what kind? what the process of manufacturing of this steel, because it's quite different, the tensiles, the limit of tensiles. Huh? So we have to be very careful on this. But it seems that it's a possible way. I understand that the cost of the finite elements analysis tools are quite expensive. But when you think about test center, let's just think, you know, test center, the equipment that you have also costs a lot of money. So maybe the test centers can move somehow to a virtual and physical tests, and in order to get quickly results or optimize results or things like this. Just the idea of the work was this. We intend to continue the work to dynamic tests as well.
Thank you, Carlos. I do see a lot of benefits, especially from the designer side. Before they put anything in construction, it would be very interesting for them to see results before they have to assemble anything, knowing ahead of time what materials they're gonna select. That's a good opportunity for that too. I think, Stephen, you wanted to say something if I'm not wrong.
Hi, good morning. Or good afternoon in some places. Yeah, I was just wondering if the virtual modeling takes into account different angles that could be applied to different components of the chair.
Your question is if we can consider different angles, it's like that.
Correct. So like a downward force on an arm support.
Oh, yes. For the armrest, we have used the exactly angle specified by the standard, but we could change that angle. No problem. It's quite easy. Yes, it's easy. No problem about this.
Right, definitely. I was just saying, so some of the tolerances in the standard, you know, using the tolerance, you might have a plus or minus 2 degree angle that could be applied on a particular component, and that angle may change the force applied to the structure.
Yeah.
So it's just interested in that. So
I'm also wondering, for those designers who may not have access to pay for such expense to do the fine elements, I wonder if maybe if there's a comparable software that's free that can be easy to replicate with something similar to what you just presented.
I don't know any free software for companies. Okay, university usually you have access to some softwares, but there are packages like I'm not doing any propaganda here, okay? But there are packages like SolidWorks who usually have a model which works with tension analysis. It usually is quite simplified model, but it's the first can be very good as a first guess. But usually these tools are very specific. This is the main issue for me, how you can put this inside of this contest of test centers.
Thank you, Carlos. Thank you everyone again for your questions. Now we're gonna go into our next presenter, who is Nichole Orton from the University of Michigan. And Nichole, feel free to share your screen and let me know if you want me to put you as a spotlight if you're gonna share your camera.
All righty. Everybody see my screen?
Yes.
Okay, great. I'm kind of starting in the middle of a couple presentations because I'm not sure how familiar everybody is with UMTRI and the work we do. So UMTRI is the University of Michigan Transportation Research Institute. And we've got a great group of people here who do a variety of different research and testing on wheelchairs and wheelchair related products. So we have even in the past had crash testing, not crash testing, but field crash investigation teams who would go. We had any crashes in the area with wheelchairs involved, we'd send out a crash investigation team and sort of see what happened, things like that. We have a great modeling team as well, which we primarily are modeling to see how we can design restraints and airbags and things like that that would work effectively with the wheelchair. So less on the wheelchair design end of that. We recently have had several projects funded where we're looking at toward the future with electric vehicles. So we're funded by our M-City group, and we made I think I've got it here. We developed design guidelines for accessible automated vehicles. So this is like a guideline that goes through different aspects of a vehicle. So if you were to be designing an electric vehicle, a new vehicle from scratch, where you now have to consider accessibility for a person seated in a wheelchair from the get-go, we wanted to give some ideas on what sort of features are good, better, or best. That's sort of what we're doing. So we're providing good, better, and best design guidelines for all of these different areas. So a report on that's coming out soon through M-City. And what else? So I think the ones that I want to talk to you most about, we're also developing a side impact procedure through NHTSA's funding. So that's National Highway Traffic Safety Administration here. But the bread and butter of what we do every day is testing frontal impact for different types of products. So let me switch my share real quick and go to this guy. So Mary Maneri, myself, and Kathy Klinich are all sort of the main researchers in this area. Miriam and myself are both involved in the RESNA Committee on Wheelchairs and Transportation, or COWUT, and the ISO, sort of the sister committee in ISO WG6, which develops standards related to using your wheelchair inside a vehicle, as a seat inside a motor vehicle. So I think I just said that stuff. So these groups are sort of made up of engineers like myself, consumers, advocates, caregivers, manufacturers of the different products, like the tie downs and occupant restraint systems, the wheelchairs themselves, the seating, vehicle manufacturers, and clinicians. We even had some policymakers provide input, like from FDA and whatnot. So our main concern is to look at crash protection for people who must remain seated in their wheelchair, and sort of make sure that they're achieving at least the same level of safety as a person seated in the manufacturer vehicle seat. So the standards that are at play in this arena are related to these products. So we've got WTORs, which are the tie downs and occupant restraint systems. So we've got WC18 here in the US as a RESNA standard. And the ISO world equivalent is 10542-1. There are some differences, but we do try to harmonize as much as possible. Then for the wheelchairs themselves, to make sure the wheelchair is crash worthy, we have WC19, which is part 19, as Jim was mentioning earlier, 7176, part 19. And then for the seating systems that we want to test independently of a wheelchair frame, we are able to test using the methods in WC20 or ISO 16840-4. And the last category is for like a low G environment, or a large accessible vehicle environment, where we are looking more at a containment system as opposed to a restraining system. For, you know, big buses and things where you're not going to have as high forces and whatnot. And that's section WC10 for RESNA, or 10865-1 in the ISO arena. So I'm going to show you some of the things we do for the top three mainly here. So for WC18, that's where we're testing tie down systems and occupant restraint systems. the standard includes many things, like labeling considerations, design requirements. It's got a bunch of design requirements for the tie downs and the occupant restraints. But then it's got in Annex A, it's got the crash test, which is a 30 mile per hour or 48 kph frontal impact, where we use a surrogate wheelchair that's 85 kilograms and typically using a mid-sized male hybrid 3 crash dummy here. So I can come over here and show you I think Jim showed some of these as well when he did his presentation, but this is our surrogate wheelchair. So it's basically just a rigid reusable tool so that we can test our different tie downs. So we can do both docking type systems or strap type tie downs, because we've got experiment points here. We can test with a belt anchored right to the wheelchair, or with systems that come with belts anchored to the floor. WC18 actually requires, if you have a kit for general use where you have, that includes an occupant restraint system that anchors to the floor, there's a second test now required, because WC19 wheelchairs are in the market, which can have integrated seat belts attached to, so all the restraint forces are attached to the wheelchair. So the second test of the tie downs would include the wheelchair, a surrogate lap belt anchored to the wheelchair, just to see how the tie downs can handle those forces. Does anybody have questions? No. Okay. So then let's see what else. So WC19 is where we're doing our testing the actual wheelchairs that are meant to be used as a seat in a motor vehicle. So for those, it's a similar test. It's a 30 mile per hour frontal impact on our sled here. Here, I'll just do this. For that, we are strapping down the wheelchair with our surrogate tie down system. So we've got, for WC19, we have a very prescribed set of surrogate tie downs that are just made of components that are reusable, so we can replace webbing and things like that. We've got a strain gauged anchorage here, rod end at the bottom, so we can measure the forces on the rear tie downs. For each test, we replace the webbing. We've got these split drums that enable us to fix the tie down at a specific length, and reusable hooks for ours. The ISO standard part 19 will allow you to use commercial tie downs for this, as long as they are crash worthy as well. But this is what we use, and we typically also use a surrogate shoulder belt paired with a commercial wheelchair anchored lap belt. And we have this knee leg stopper here to keep the knees from hyperextending during the crash, which is in both standards now. And when we do these tests, we're looking for things like how far forward does the wheelchair and the occupant move? You know, the structural integrity of the wheelchair itself. Do we have any major breaks in the frame? Does anything break off and go flying? Because there's limits on those things. Whether or not anything breaks and creates a sharp edge that the occupant can contact and whatnot. We also, this little zone here that I have, this plexiglass zone, is in the standard. It's we're requiring that the wheelchairs have their securement points within this check mark zone, which is a zone that we developed that is based on the minimum and maximum reaches of different tie down lengths for a strap type tie down. So we want to make sure that any securement points on the wheelchair are going to be reachable by a typical set of tie downs, and that they can tension properly. Right. So then for WC20, where we're doing the seating systems that are independent from a frame. We use this chair here. This is the green, our surrogate wheelchair frame. So it is a rigid frame that we validated against several commercial frames to provide sort of a worst case loading situation to the seating system and its hardware. So it's tested with the surrogate tie downs as well. And then we use a commercial seating system and their own attachment methods. So we've got, this frame can be at different widths. We've got different cross members that can create different widths of wheelchair for the frame. We've got different seat rail dimensions. So if we need a wider or a square tube instead of a circular tube, larger diameter tube, we can swap those out. We don't typically do that because most of the seating systems can fit on a 1-inch diameter rail like this. We have deformable elements on this. So we've got this aluminum caster attachment here. I don't know if you guys can see. You can kind of see it on the other one. So these deform with each test to sort of manage some of the energy and make it more similar to a frame with its deformation so that it's not just such a hard, rigid system. We also have deformable aluminum elements for the seat back canes here that will bend and give some, because we know most wheelchair seat back canes will give some for a real wheelchair. But these are a controlled way of and repeatable way of managing energy in a really realistic way for this crash as well, which is also 30 miles per hour. Let's see what else. Does anybody have questions so far? Here, I'm going to stop share. So our sled here is a rebound sled. It's a bit old, an older model, but it's 45 feet here. Starts at this end. It's got a pneumatic piston in between, which launches or accelerates the sled on the rails here. And then it will achieve about 17 miles per hour coming into this nitrogen air spring at the end, and it's bounced back at 13 miles per hour or so to achieve the total delta V of 30 miles per hour. What else? So this is the mid-size male dummy that we use. We always run with head and chest accelerometers in there, even though right now the standards don't have any requirements related to, or like injury measures related to the data, just because we don't know what kind of injury limits or risk values we have for people who have, less muscular tone and probably less bone density, things like that. Yeah, that's the mid-sized male. We've got a large male ATD setup over here. So the WC19 test also includes some non-destructive tests. So this is the setup for the securement point accessibility test. So we put walls around the wheelchair that would encompass like I believe this one's a 50-foot length wheelchair space on a bus or whatnot. So we want to make sure that a bus driver or a caregiver can connect all 4 tie downs in a reasonable amount of time, and that there's no problems reaching the different securement points with a hook. So for this test, we use just a surrogate hook like this. We have somebody with a timer, and we go ahead and attach to all the different securement points on the wheelchair. And this one, we rarely have we've never had anybody fail this test because you have 10 seconds to attach each hook or detach each hook. But it really gives us an idea of the difficulty level. Like if you've got something interfering with the opening of the securement point, you'll see it in this test and it'll be noted. What else? We also do a tilt test. So we check lateral stability of the wheelchair for WC19. So that's actually done on our sled platform here. We put these big hinges on right here and lift the entire sled plate up to 45 degrees and measure how much lateral movement the wheelchair makes at the seat junction. And there are zones. So a good amount of lateral excursion is 0 to 20 millimeters. Acceptable is 20 to 40, and then 40 plus is poor. So we just want to have an idea of what kind of stability the wheelchair will provide. The other tests that we do, we will attach tie downs on this platform and measure whether or not the strap deviates from a straight line path to the anchorage point on the floor. It can't deviate more than 40 millimeters from a straight line. We check whether or not there are any sharp edges on the wheelchair within 50 millimeters of the tie down webbing, like the center of the tie down webbing. So there can't be any sharp edges, which is defined as a radius of 2 millimeters or less. Then we put on a seat belt, a wheelchair anchored lap and shoulder belt, and check to make sure that with the belt anchored to the floor, that there are no sharp edges on the wheelchair that could potentially contact and cut the belt webbing. We make sure there are no structures on the wheelchair that hold the seat belt away from the hips and the shoulder, because that would decrease the safety. What else do we look at? We make sure you're getting good wrapping on the body. So I think those are the basics in the standard. I mean, there's a lot encompassed in the standards that we don't test here because it is a voluntary test. A lot of the manufacturers will do their own in-house verifications on like labeling and design requirements. We've got stuff for user manual instructions and installer instructions in the standards. And so they're kind of on their own with those things. Here are some of the other dummies we use, our hybrid 3 dummies. Does anybody have any questions?
So, Nikki, I've got to ask you a question, and you're all waiting for it.
I know. I saw you.
No, this is a straightforward one. On the 16840 surrogate test, I noticed that section 20 has. Is it a standard requirement for an integrated lap belt or wheelchair anchored lap belt on the surrogate wheelchair?
It is. So yep, go ahead.
Do you ever conduct tests with vehicle anchored?
We do not unless it's requested.
Do you ever feel that the lap belt attached to the wheelchair is interfering with the load imparted by the seating system onto the wheelchair?
So we did do a lot of validation testing for WC20 to determine whether or not to use the integrated or independent lap belt. So we put load cells, like pancake load cells, underneath the seat rails and between the seat back posts and like a secondary post, just to measure how much rearward force we're achieving and how much downward force, well, shear force and downward normal force we're achieving. And there were some trade-offs. So the vehicle anchored belts, the independent belts, provided a worst case loading scenario for the seat back, because as you probably know, during those tests, the dummy kind of, it's less coupled to the seat. So the dummy kind of gets a lot of rebound energy. So it kind of launches up and backwards a lot more because the seat belt is not attached to the seat. But then for the wheelchair anchored situation, we saw more normal and shear loading on the seat pan itself. So we kind of had to look at it, and they weren't that far off on the seat back loading. So we decided to go with the wheelchair anchored scenario for that reason.
We were asked a question here testing with Jim by one of the seating manufacturers, and he was saying which would be worst case, and we, without using instrumentation, just by seat of the pants, we said vehicle anchored, because we're not holding back. We need to measure the kind of compare the two excursions of the wheelchair and the knee.
I would say the vehicle anchored affects the excursions of the dummy a lot more.
Yeah.
Right.
Worst case. Yeah. Okay. Thanks
Yep.
for that.
Yep. Anything else? I don't have an example test to give you guys today, unfortunately. I'm the only one here today. It's not safe to run. Hi, Jim.
Hello. Yeah, I just want to ask about this. You mentioned there about the rebound then of the sled. How do you think that affects then the trajectories then?
It's I think it's the same thing. The only difference we have is that on initial takeoff, we do have some jostling of things right when we launch. So there's like a little secondary pulse. It's very minimal when it takes off, but the main impact event is the same as you would achieve during a barrier test or a.
Yeah, because so I mean we run it some similar way. We do a decel test rather than an accel test.
Yeah.
So we find it works. That works okay. So we have them. You just can't get away from the rebound. You're always going to get that element to the test. But as long as it's the change in velocity, yeah. And the second part I was going to ask you is, how do you do your trajectory measurements, Ben? What software do you use?
So we're taking video at 1,000 frames per second, and we use TEMA.
Okay, yeah.
We occasionally use that. Sometimes if we are in a hurry and just want to see, we'll use ImageJ, which is a free software online, which allows you to, just do pixel measurements of.
Yeah. So with TEMA, is that 2 cameras or 1?
We do 2D, so it's 1 for.
Right. Yeah. Yeah.
So, I mean, we do use 2 different cameras to view the different excursions. So the forward camera we use here, over here, is to capture the forward excursion measurements. So we're looking at the wheelchair forward excursion, the head and the knee excursion of the dummy during the frontal impact part where they're moving forward. And then our rebound camera here compares our initial rear head position coming into the maximum rebound rear head position.
Yeah. That's always annoying, isn't it? With you think you set the camera up to capture the full range, and suddenly it just agonizingly goes out of shot, doesn't it? Yeah.
So we've got the overlapping cameras just to cover it, and we usually get the measurement. And if we don't, something else has gone wrong with the system, like something has broken,
you hope if that happens, I always think you hope something else has failed before that, so you can you can save your blessings, can't you, then?
It already broke.
Yes. You don't have to measure it. Yeah. I know that one. Yeah.
Yep.
Okay. Thanks.
Nichole, we had came up in a conversation one of the previous meetings, ISWP, where we were talking about perhaps in the developing world, in the third world, in Africa, certainly on the African continent, maybe other places in the world too. The 20G 48 kmh pulse that we're testing, subjecting wheelchairs to, is pretty inappropriate. I mean, I think that Steve Williams would, be totally inappropriate for the kind of transport conditions that you'd see in the third world. I don't know whether you can still say third world, but anyway, you know what I mean. What do you think about perhaps for the benefit of wheelchair manufacturers in less resource settings, if we were to consider doing something else like a 10G test?
I don't see why not. If that's something that we see would be valuable, and that we can really justify using that instead of this fairly severe test that we're doing. I don't know enough about that environment to speak.
I think it was Bob. You were sort of we were talking about doing a test at a lower G level to perhaps try and encompass a wider range of accident scenarios. Same in a similar vein to whole vehicle crash tests. You know, you cover by doing lower speeds, you do cover more accident scenarios. So so potentially you protect more, you reduce the risk for a greater range of people and different accident scenarios by doing one. Yeah, because we were
Definitely
just
worst case, right? We're
it was like the 20G really is a.
But it
Is a
may
worst
drive like
case scenario.
over engineering, right? Over engineering to pass.
We could perhaps bring more solutions to people if we were to just tune it back a little bit, and we might, you know, enable access to transport for more people with less complicated, less expensive, lighter products. Maybe, you know, those that can like the bamboo scene, you know.
Yeah. I maybe we could make an alternative test, but we'd have to have real clear reasoning why you would test to one versus the other. And I'm not sure what that deciding factor would be.
Yeah, I think what we're looking towards doing really is probably just running a couple of trials and seeing how a standard Part 19 wheelchair, how that would perform in a 10G test. You know, it's rather than having perhaps manufacturers optimizing their wheelchairs to 30 and 20G levels, is there something which is perhaps missing then at 10G? I mean, we picked 10. Yeah, we picked 10G out as a, you know, just as a half of 20 really, with no specific scientific evidence of accident analysis, but it's it was something we were going to try.
Only, Jim, that it's the frontal crash characteristics of an M2 category vehicle, which is a you know, like a minibus type van type thing.
Yeah.
Whereas, you know, the 20G is specifically for cars and maybe smaller vans,
right?
Larger vehicles. And you know, I think in Africa, if someone has a disability and they'll probably put the wheelchair on the roof. You know, they get lifted in, but certainly the presence of tie downs and rails in floors in Kenya, which I know about, Tanzania, forget it. You're being up there on the roof with the goats, you know. So I don't know, just maybe for ISWP, it's the kind of territory which perhaps is more relevant.
Yeah, thank you. I think it would be definitely a good thing to explore alternative methods for different settings, different environments, especially those that are going to have different conditions for transportation and for other environments where they need to bring their wheelchairs as well. So definitely something that it's worth discussing. And I'm happy that now we also have some different members from different countries that can provide their own insights on their context. So I think that is very important to also bring into ISO, because, you know, like a lot of the testing have been done and designed for high resource settings, but the majority of the countries in the world are not with the same conditions. So I think the standards should look into addressing worldwide different settings, different environments, different weathers, etc., so that it's going to be more suitable and more realistic for other countries as well. But it's great to know that you also have that perspective and willing to see what else we can do. I also want to thank everyone for joining our meeting today. I know we are a little bit beyond the time, so it's great to hear that everyone is engaged and you have a lot of things to discuss. Sorry, we have to cut you off, Nick, but thank you for your presentation. This is just a quick reminder. I'm going to be sending a couple emails to cancel all the wheelchair testing centers, since we're going to be merging with the ISWP Standards Working Group. So our next meeting is going to be on December 14th, and we're going to meet at noon or 12 p.m. US Eastern Time. So thank you, everyone, and see you in December. Have a good one.
Nice one, Stephanie. Cheers.
Thank
Bye.
you. Bye.
Thanks.
Bye.